4.1 in college algebra is going to be getting into polynomials. So we're going to talk about what types there are, what we know about them, to graph them by hand without a graphing calculator, and all kinds of things. So before we get there, we're going to do this 031 topic of just some definitions, all right? So looking at the first term, it's literally the word term, all right? So what is it? It's an expression in mathematics that involves the product of numbers, variables, and or variables with exponents. So product means that they're only going to be multiplied, guys. So if you see a plus or minus there, those are two separate terms being separated by an addition or a subtraction symbol. So they're going to be shoved right next to each other to be considered a term. If it's, since a term is just one single thing, it's called a monomial, mono meaning one, okay? So here's some examples. 5x squared y, negative 3a, x to the fifth, 8. So notice you can have like a handful of variables with different exponents, or just one number, one variable, or just variables, or just a number. So that any kind of combination of that. So what we're going to pay attention to, this isn't defined, but the coefficient is the number part of the term, okay? So this is the number part of the term. All right, so what we're going to do is we're going to look at these three terms they gave us and list the coefficient, aka the number part. So looking at this first one, 5x squared y, what is the coefficient of that? 5. Looking at negative 3a, what's the coefficient of that? Negative 3. And looking at x to the fifth, what's the hidden coefficient? 1. Is everybody okay with that? So the coefficient is just the number in front. So this is technically a hidden one right there. All right. So then, now that we know what a term is, and now that we know the coefficient of a term, we can talk about a term in the way of degree. The degree of the term is the sum of all the exponents, okay? It's the sum of all the exponents of that term, all right? So if you just have one variable, that one exponent is going to be your degree. But if you have multiple variables, you're going to add those exponents to get the degree, all right? So again, same kind of little examples we're looking at here. So we're looking at 5x squared y. Technically, what is y's exponent? 1. So what's the sum of the degrees?
6.
Nope. Because we're just adding the degrees. So what do you get when you sum them? Just 3, right? Because you have x to the second, so that's the second degree, and y to the first. So when you add 2 plus 1, you get 3. So that's to the third degree. Okay. What about example 2? What are we going to do? We're going to add those 3 numbers. What do you guys get? 9. What is a's variable, or exponent, excuse me? 1. And then this is kind of tricky because the whole idea of a degree is that it's the variable's exponent, but if they don't have a variable there, there's actually like a hidden one there, and it's to the first, or the 0 power, right? Anything to the 0 power is 1. So technically this could be like x to the 0 power, okay? So any just number is of degree 0 because it doesn't have a variable, okay? So maybe just think absent of a variable means absent of a degree or something. That's degree 0. Because you could put a there, y there, I don't care. You put any variable there, but if it's to the 0 power, it's technically 1. So, all right. So then, now that you know what a term is, what a coefficient of a term is, and what the degree of a term is, we can combine them with addition and subtraction and start making polynomials. What's poly mean? Multiple or many, right? So poly just means multiple or many. And notice again, it says it's the sum or difference of terms. Meaning now we have these products that we're going to add or subtract. All right, so we can get kind of specific. It says here, notice the terms of a polynomial cannot contain negative exponents or radicals involving variables. That's actually what we're going to talk about in chapter 4, 4.1 specifically. What defines a polynomial is that all the variables are positive whole numbers, okay? So like you shouldn't have a 1/2 power, you shouldn't have a -2 power. All right, so when you have a polynomial, it's just kind of a blanket term for many terms added together, but specific ones have specific names based on how many terms you have. So looking at this first one, we have 5x squared y plus 8y to the fourth. How many terms are located in that polynomial? 2, right? So this is a term, and this is a term. So what is the prefix meaning 2? Bi. This is a binomial. So that's the more specific name that it's talking about. Right? Like bicycle has 2 wheels. All right? How many terms does 3x squared minus 6x plus 1 have? 3. So what's that called? Trinomial. You look at you guys. And then we already talked about one term. We kind of talked about right up at the top. That's a monomial. You might want to guess uninomial? Uninomial? That'd be hard to say. So it's a monomial. Is that okay? So we know terms, we know their coefficients, we know their degrees, and we know what they make when we combine them with an addition or subtraction. So now that we know that they make polynomials, we can talk about degrees of polynomials. And the degree of a polynomial is just the largest of the degrees of the terms, right? So a polynomial is made up of different terms, and each of those terms have their own degree. Just whichever one has the highest, that's the degree of the polynomial. And be careful, because it's not always in order. They're going to try to be mean and scramble them on you and everything. So sometimes what I do is I just individually write the degrees of each term under itself and then say, okay, which one's the biggest one? So looking at this binomial here, this first term, 5x squared y to the first, that is degree 3, correct? And the second term, 8y to the fourth, that's just degree 4. So of those 2 degrees, which one's the largest? 4. So that's a 4th degree binomial. Is that all right? And then just kind of do the same thing with this trinomial. This x is to the 2nd degree, so it's degree 2. This x is to the 1st degree, so it's degree 1. And remember, a constant is just 0. So which one's the biggest? 2. So that's to the 2nd degree. And then what do we have? 5, 3, 0. And so this is the 5th degree trinomial. And then trying to fool you, because you see that 3, but we don't care about the degree of a number. We care about the degree of the variable. So that's actually degree 0. Yeah. These were kind of nice. What do I mean by that? That they were all in order. No, not necessarily. Number 1 wasn't in order, right? So they can scramble them. So just don't always think it's that first term who leads the degree. It's the largest degree that we need to look for. All right, so then each of these can be classified as either an even degree polynomial or an odd degree polynomial, and it's exactly what you think. Whatever the degree is of that polynomial, if that polynomial is of an even degree, it's called an even degree polynomial. And if it's an odd degree, it's called an odd degree polynomial. So looking at these, none of them repeat, so let's first decide what the degree of the polynomial is, and then decide is that an even number or is it an odd number. So looking at this like quartinomial or whatever we call it, right? Polynomial. This is degree 3, 2, 1, 0. So what's the degree of that polynomial? It's the 3rd degree. Is 3 an even or odd number? Odd. So this is an odd degree polynomial. And then again, just go to example 2. This is the 4th degree, 3rd degree, 1st degree. So what's the degree of that polynomial? 4th, and so it's an even degree polynomial. And then last but not least, we have example 3. We have 1st and 3rd degree, so really it's a 3rd degree polynomial, so it's an odd degree polynomial. And the reason why I'm pointing this out is because this is going to lend us to when we start graphing these. Even if you're to a 4th power or a 16th power, if you're an even degree polynomial, you kind of resemble each other. And even if you're a 3rd degree or a 17th degree, as long as you're an odd degree polynomial, you kind of resemble each other. So it says, using a graphing calculator to graph each of these functions, what do you notice about their shapes? So let's get our graphing calculators out. And you're going to notice when we graph the 2 odd ones, they kind of resemble each other. Okay, let's see if I can turn this on. So I'm going to graph the first one in my y equals button. So y equals, I'm going to clear what I have there, and I'm just going to plot my first one. So 4x to the 3rd plus 5x to the 2nd minus 9x minus 2. And I'm just going to graph it. And what you're going to notice is when we have this function, oops, he's like glared. He's like right in the glare. There you go. He is like the cubic that we've seen before. So way back when in like section, what was it, 2.5, when we were graphing functions, remember the cubic was the snake where it went up and kind of crossed through the origin and kept going? So an odd degree function is always going to have the ends going in opposite directions. What do I mean by that? This end is going down to negative infinity, and this, I feel like 2 people are listening and 2 people aren't. Okay. So this end is going down to negative infinity, and this end is going up to positive infinity. Okay. So odd degree polynomials, their ends are always going in opposite directions. Now, let's clear that out and type example 2. Okay, and I can double check yours if it, so example 2 is negative 2x to the 4th minus 8x to the 3rd plus 7x. And I'm going to just graph it. And yours, Corey, might still have like stats in it or something like that, so we'll have to double check. So again, you can't see everything that's going on here, but if we zoom out, let's just go to like negative 20, 20, go by 2s. And you guys don't have to be doing this right now, I just kind of want to point it out. It's still not going to see everything, but we know what a second degree looks like. It's a quadratic, right? So a quadratic goes down and comes back up, or goes up and comes back down. That's what's happening here. We can't see everything, but guys, the ends are going in the same direction. This is going down to negative infinity, coming up, coming back down, and then going back down to negative infinity, okay? So if it's an even degree polynomial, your ends are going in the same direction, all right? So we're going to make that note on here. So even degree is ends are in same directions. And we'll do a little sketch, and I know it looks weird, but actually your book refers to it, my math lab will refer to it, your worksheet will even refer to it. We don't care about what's happening in the middle, so we just do this, and then you kind of go do 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 do, and then put your arrows both up. See how like we don't care what's happening in the middle, but we just want to show that our ends are going up, or they're both going down. And you guys know why it goes down. What made a parabola open down is your first term was negative. So notice this, it had a first term that was negative, so it opened down. All right, odd degree, ends are opposite direction. So remember, the odd degree is kind of like that cubic snake, right? So the first end is kind of going down. We don't care what's happening in the middle, and the second end is going up forever. Or if there's a negative there, the first one is actually coming from infinity. We don't care what's happening in the middle, and then it's going down. And we're going to keep that in mind when we're graphing.